Okay, in our last two lessons we learned how to find probabilities that z-values lie in particular ranges. Now let's use what we've learned and apply it to some specific data to find probabilities of getting certain data values. So let's begin with this. What we know is that cholesterol levels for young males are normally distributed with a mean of 182 milligrams per deciliter and a standard deviation of 38 milligrams per deciliter. It's important to recognize that most measurements we deal with will have units, but we'll dispense with the units as we go through. It's a little clumsy to write them every time. So let's start off with the question of what is the probability that the cholesterol level for a randomly selected young male is between 144 and 220. Well, if we take 144 and subtract it from our mean of 182, if we take 182 minus 144, we get 38. So what that tells us is that 144 is one standard deviation below the mean. And similarly, 220 minus 182 is 38. So 220 is one standard deviation above the mean. So we could draw a picture like this. We could show our normal distribution. And we're going to alter the pictures a little bit from what we did before. We'll put actual data values down here along the bottom. And so let's call those X, capital X. And up above in here, we'll put the corresponding z-scores. So right here under the top of the curve is our mean of 182. The 144 is over here to the left. Oops, 144. And over here to the right somewhere we have the 220. And let's put the corresponding z's up here like I said. So when we're at the mean, remember the z measures how far we are above or below the mean. So the z at the mean is 0. The z at 220 is positive 1. We're one standard deviation above the mean. And the z at 144 is negative 1, or one standard deviation below the mean. So if we want to know the probability that a randomly selected young man will have a cholesterol level between 144 and 220, we can see that we're really asking what's the probability that their cholesterol level is within one standard deviation of the mean. And we know from the 68, 95, 99.7 rule that that is 68%. So that's the probability of getting randomly selecting a young male whose cholesterol level is between 144 and 220. Now that's all fine and dandy, but the question is, what do we do if the values we're given don't fall on whole standard deviations above or below the mean? So let's take a look at an example, and this will show us how we deal with this kind of thing. So let's suppose we want the probability of randomly selecting a young male whose cholesterol level, let me just abbreviate this, cholesterol level is between 100 and 200. And that's what we're looking for. Okay, so in a picture, we've got a picture that looks something like this. And again, let's put our data values down here. So here's 182 for the mean, so a z-score of 0. And then somewhere up here we have 200, not too far above this, so there's our 200. And then down here somewhere we have 100. And we're looking for the probability of having a cholesterol level between 100 and 200, which means somewhere in this range right here. Now it should be clear, since our standard deviation, remember, was 38, that this 200 is certainly not a whole number of standard deviations above the mean, and it's very unlikely that this is two standard deviations below the mean. In fact, we can see 38 is a little less than 40. If we went 40 and 40, we'd be at 102 which would be about -2 standard deviations, but it would actually even be a little bit larger than that. So we can't work in whole standard deviations this time. But what we can do is find the z-scores that correspond to 100 and 200. Now, so let's do that. So for when x equals 100, okay, and we'll use, again, x for data values, z for z-scores. So what we have when x is 100 is that our z is 100 minus 182 over 38. And that gives us a z-score of -2.16. And for x equals 200, we get a z of 200 minus 182 over 38, which is 0.47. Okay, so those are our corresponding z's. I didn't leave myself a lot of room to write those in, but let's erase and make a little room. So we have 0.47 here and -2.16 here. Now, let's use some notation like we used before. If we're looking for the probability of a cholesterol level between 100 and 200, let's write that like this. We want the probability of being between 100 and 200, so we want something like this. But remember, for data values, we're going to use x rather than z. So we want the probability that x is between 100 and 200. But if we look at our picture, we can see being between 100 and 200 for x is equivalent to being between -2.16 and 0.47 for z. So this is equal to the probability that z is between -2.16 and 0.47. Now, this is the kind of thing that we just found in the previous lesson. So if we go to this, we can see, remember that if we want the probability of being between two values, what we do is that's the probability of our z being less than or equal to the larger value, 0.47, minus the probability that the z is less than or equal to the smaller value, -2.17. And so, let's see, did I get those right? No, that's 2.16 in this case. So then we can go directly to the standard normal distribution table and pick these probabilities off of the table. So we find that this first one is 0.6808, and the second one is 0.154. If we subtract those two, then we end up getting 0.6654, or 66.54%. So that's the probability that a randomly selected young male will have a cholesterol level between 100 and 200. Notice what we do to do this is we set up the probability we're looking for, and we just translate everything over into z's. So we still have a probability, but instead of looking for the probability that x is between 100 and 200, we look for the probability that z is between the two corresponding z values that correspond to our x's. So that's pretty much all there is to this. So let's have you try a couple of these. You might want to jot down again that mean and standard deviations. So get that down somewhere. Remember, our mean is 182. Standard deviation is 38. You'll need those in order to do the exercises I'm going to ask you to do. So let's start off and let's ask what is the probability of selecting a young male with a cholesterol level below 150. So that's what we're looking for, the probability of selecting a cholesterol level below 150. Let me put this back up for you to take a look at as you're working on that. I think I'm not going to be able to let you see the whole thing, but there we go. You can use that as a guide for answering this question. So pause the tape now, pause the video, and I'll go over this when you start it back up. Okay, so if we want the probability of a cholesterol level below 150, let's draw a picture of what we're looking for. So here's the mean of 182, a z-score of 0 above that. 150 would be down here somewhere. Again, that's an x value. These are z's up here. So we need to find the z that corresponds to 150. So that would be 150 minus 182 over 38. Now, I didn't do that ahead of time. Oh, yes, I did. Okay. So the corresponding z is negative 0.84. All right, and let's see. So I should have drawn this in initially. We're looking for the probability of being down here. Certainly should be quite a bit less than 50%. There's our z. So let's take this, remember, and let's write it symbolically. This is the probability that x is a cholesterol level, is below 150. So that's less than 150. And again, like we said earlier, it doesn't matter whether you have less than or equals to. They're the same value. So this is one of the form that we can read straight off the table if we get it in terms of z first. So the probability that x is less than 150 is equivalent to the probability that z is less than, and I'm going to put the equals in here just because we've been using that z is less than or equal to negative 0.84. And that value can be looked up directly on the table. When we do, what we get is 0.2005, okay, or 20.05%, which looks reasonable based on our picture over here. Okay, so that's that one. Let's do a different example. So let's find the probability of a young male. So a young male with a cholesterol level above, let's say, 220. Okay, so what's the probability of finding a young male with a cholesterol level above 220? So you work on that for a few minutes. When you're done, go ahead and start the video back up and see how you did. Okay, so looking at the picture for this, here's our 182 again for our data value. So that's an x, and that corresponds to a z of 0. 220 is going to be up here somewhere. Okay, in fact, we worked with 220 a little bit earlier. And we're looking for the probability of having a cholesterol level above 220. So we could write that symbolically, that we want the probability that x is greater than or equal to 220. And that's equivalent to, if we know the z, so let's see, what's our z for this? The z turns out to be 220 minus 182 over 38. Okay, and in that case, that turns out to be exactly one standard deviation, so we get 1. So what we're looking for is the probability that x is greater than or equal to 220, which is equivalent to the probability that z is greater than or equal to 1. Now we could use the 68, 95, 99.7 rule, but let's use the table instead. Remember, when we want to find a probability that z is greater than some value, that's 1 minus the probability that z is less than that value. So we want 1 minus the probability that z is less than or equal to 1. So we go to the table and we find 1, and that's 1.00. So we'll come here to 1.0, and then here's the column for 0, 0 right here. So our value is 0.8413. That's our probability. So we have 0.8413. Whoops, that's this probability. So we need 1 minus that. So it's 1 minus 0.8413. Okay, and let's see, if we do that subtraction, I'm going to have to do this in my head. I didn't do it ahead of time. I think that's going to be 0.1587, I believe. Okay, again, you might want to check me on that. And so 15.87%. So that's the probability that a young male would have a cholesterol level greater than 220 would be about 15.87%. So that concludes our lesson on finding probabilities for normally distributed data. And at this point, then you should find some other examples, some other data sets, and you can work some more exercises involving these concepts.